This is Mark Coleman for Container Solutions, speaking to Kelsey Hightower from CoreOS. Hi, Kelsey.
Hey, how you doing?
Very well, very well. How are you?
Fantastic.
Good, good. We're going to jump straight into it since it's supposed to be a fast-paced sort of interview. First, I wanted you to introduce yourself to whoever's watching this.
I'm Kelsey Hightower with CoreOS, a place where I wear many hats, one of them being developer advocate, engineer, currently hacking on etcd, Kubernetes, and the overall experience for people looking to get into distributed computing.
Okay, short to the point. We like it that way. Um, so CoreOS, people would have had to have spent a fair amount of time in a cave for the last year or two to not know what that is. But just in case there's anyone watching and they're thinking, what is this CoreOS? Could you explain a little bit about what CoreOS is, what problems they're trying to solve?
Right. So the way I like to explain this really quick for people is CoreOS provides like the foundation for building distributed systems, right? And at a higher level is basically Google's infrastructure that you can download, right? So a lot of people are excited about containers. And once you start adopting containers, the next thing you want to do is kind of run those at scale, right? So CoreOS kind of gives you a containerized, container optimized operating system and the tooling around it, things like etcd to handle things that will come up when you're building a distributed system, and higher level tools on top, which are to come from CoreOS.
Clear. Okay, so this is very much in the area of the sort of cluster management thing we're seeing right now. CoreOS is one big player, a Mesosphere are in there as well, doing a similar sort of thing. Um, what's your history with CoreOS? Because you say you're a developer evangelist now, but you were head of IT for Puppet or PuppetLabs for a while.
Yes, I was at PuppetLabs. After PuppetLabs, I spent some time as a director of engineering at a company called Monsoon Commerce. And so I have a very diverse background. So, everything from sysadmin, the ability to write code, and actually managing people, I like to think effectively. I'm a people person. So, my skills range from the business side all the way down to my Vim text editor running on my machine.
So that's really, there's a lot of talk at the moment of the full stack developer, and you've literally gone from head of engineering to hacking around and talking about it, if that's how I'm supposed to understand the role of developer evangelist. How did that,
Yeah,
how did that happen? That's normally not a career path we see so often.
I think everyone that works at a company that allows their developers to interact with the community in any form, whether that community is your paying customers or at an open source conference. So I think every engineer has the responsibility of advocating the things that they're building. So for me, I like having that particular title in addition to my other responsibilities because I like to go out and educate people because this stuff is hard, right? Distributed computing has been one of those topics that has been elusive for much of the IT community. So now that it's here, one responsibility that we have is not just shipping good software, but also educating the entire community on how this stuff works. So I like to advocate success for people trying to run our stuff. So it's a natural thing. Right? If you're doing any type of leadership, you have to be able to talk about this stuff, write about it, and educate people.
So, slightly off topic now, but one of the things I'm always pushing when I'm working with teams is this idea that a developer that just develops is not good enough. For me, the full stack developer also includes underneath the hardware, which means like communication skills, empathy, all this kind of stuff. Is this something you just was that just sort of your personality, or was this given to you when you were working at Puppet, or how did this mix come about?
I would definitely say Puppet had a lot of influence when Puppet was a true open source company, right? Had a huge open source community even before they had a huge commercial offering. And whenever you have a huge open source community, you have to interact with them. I mean, you live on IRC, you have to communicate not only with the team in the office with you, but people around the world, different time zones. And the most effective way of doing that is being able to write things down, being able to have async debates, right? You're not going to necessarily end a conversation the minute you start it. So all those go into just, like you described, the full stack engineer. You got to write documentation. You need to have really good commit messages with the code that you write. And you have to assume that new people will be using your stuff. So whenever you have an open source project that's successful, you won't just be relying on users that know your product well. You got to always optimize for that new user because you continue to grow over time.
Amen to that. Amen to that. If there were more of you, Kelsey, we'd be building a lot more interesting software in the world.
Thank you.
So I want to step now away from the focus on you and CoreOS and more into containers. This is, after all, for Container Solutions. Containers burst onto the scene last year, but depending on how diehard you are, some people say they've been around for years. Some people say Docker popped up in 2013. When did you get into this sort of area?
I think everyone kind of got involved with containers. It's unfortunate that LXC is often left out of these conversations. LXC really kind of brought the tooling and, exposed a lot of these things that were hidden in the kernel for time. Docker came to the party and brought the usability aspect, right? They did the whole Apple thing, right? They made containers easy to use, and not only easy to use, but easy to share with other people. And once you have those things, you get the combination of what Docker brought to containers. So I got involved with containers around the time that LXC became pretty popular, so maybe a year and a half, 2 years ago.
Yeah. And of course, CoreOS, very interesting in this area because of Rocket. So it looked like until, well, I mean, in the middle of last year, containers, that was zipped up, that was done, that was Docker's thing. But then just before DockerCon Europe, Rocket is announced. Were you there during that time?
Oh, yeah. Yeah, I was definitely there. Definitely part of the people reviewing the press release and getting the code ready. So the thing about Rocket, well, first of all, any technology in the world worth doing, there's always more than one implementation of, right? This is just good business. We see it with package managers, operating systems, mobile phones. There's just never one, right? So that's probably a very obvious thing that Rocket had to come from somewhere. It would have come from another vendor. And I think CoreOS was just the right one to do it, right? We had a lot of experience, and we also had a unique need in the space, right? So there's absolutely nothing wrong with Docker. I use it a lot for a lot of things. I was just in their office 2 weeks ago hanging out with the open source team there. So from that aspect, Docker is on a momentum to build a full-featured platform, right? And a lot of people forget Docker comes from the PaaS space, right? .cloud. So they've had all this technology before. I think what we see with Docker is them rewriting that platform from the ground up. And I think for Docker Inc., they're moving in the right direction for that particular project, right? They need to offer features that you see in things like Kubernetes. They need to offer more around container management across multiple hosts. Now, for our needs, when it comes back to Rocket, we need that simple application manager, if you will, something that can download applications, verify their signature, and allow better integration with things like systemd, Upstart. So we need to be a smaller fraction of the puzzle so we can build higher order solutions around it.
So that is a perfect segue into my next question, which is about this being a part of the puzzle. Now, Docker are famous for their batteries included but removable, or I think, or replaceable. I can't remember the exact quote. As Rocket enters the arena, the question everyone's going to be asking is interoperability, right? So people that are in there first, invested a lot in Docker, are going to be thinking, okay, so if there are unique things that Rocket can do or part of that ecosystem, how plug and playable is that going to be? My question then is, how important is it to CoreOS to keep interoperability or the chaining of tools at the forefront of product development?
Yeah, so day one, we started by creating a specification before we started building Rocket, right? So we wanted there to be multiple implementations of what we call the app container specification. So we built this thing knowing that for us, we would do one implementation, what we see today as Rocket. There has also been some work around building a libappc library written in C++ for other implementations. We've already seen FreeBSD support building their own implementation of appc on top of FreeBSD and jails. So we've already seen the interoperability we wanted from having a container specification. So our goals now are to kind of, maybe work with the other players in the market, mainly Docker, and there's also LXC, there's also systemd nspawn. So I think it benefits the entire container community to kind of agree on what does the image look like. And once we can agree on what an image looks like, then we can also talk about things like signing those images and distributing those images. In the appc space, we like the idea of using DNS for federated discovery of images, right? You can look up an image by domain name, get some meta tags, download it, and verify the signature of the person that produced that image. We believe that's going to give people the freedom to, build and store the images wherever they want. So Docker provides a lot of things that are useful for getting started and the developer experience, and I applaud them for that. We just wanted some low-level tooling that just makes it easy for people to build their own platforms.
Clear. One of the things that's come with CoreOS is a whole host of tools to go with it, a whole bunch of things with D on the end.
Yes.
Is that, so for Rocket you started with specification. Was that similar for the CoreOS cluster management? Did you say, okay, this is sort of the end goal, now let's fill in those gaps with all these tools ending in a D? Yeah.
Exactly right. So we tend to build things that don't exist, right? So we use the Linux kernel, we use systemd. One of our newer set of products, Flannel. So Flannel provides an overlay network. That tool is built specifically to address the needs by Kubernetes. So Kubernetes, which is a high-level cluster manager for containers, requires a specific networking setup where every container has a first-class addressable IP on the network. So Flannel was built to solve that particular problem. And that's kind of our motto at CoreOS. When we build something, it needs to be a true gap in the space and add value.
So Flannel's actually great. I wanted to move into some of the unanswered questions in the Docker sphere right now. There's basically two. One's sort of answered, that's networking. And I think the answer there is which way to go. Now you've got Flannel, Socket Plane, Weave, they're all coming out. When you started with Flannel, was that a gap that existed then, which has now been partially covered in the sort of Venn diagram with other tools? Or do you still see a sort of unique use case for Flannel alone?
Right. So I think the other players, rightfully so, some of these, solutions like Socket Plane and the others, they have whole startups behind them. So their plan is to probably go up the stack and do like full SDN solutions, which is the right thing to do. Mm-hmm. What Flannel does is just kind of gives you that basic need, and it's almost in line with the Docker model there, right? Well, we have to have something out of the box that works well, but we need to also make sure that if you want to bring in your own networking stack, that works. And a lot of times people forget Docker also supports different networking modes. It's just the default mode has been so convenient to use, it's become the de facto standard in the Docker space. And they're working to kind of change that with plugins and highlight the fact that you can actually change it and then make it easy to actually do the change.
So one of the areas we see here, for example, is the power strip from Cluster HQ, wrapping the Docker API so that people can just hang things on the outside. That, for me, was even though in itself it doesn't do anything, it's a very exciting development.
Yeah, that's the beauty of open source, right? Even though Docker's working hard on their own plugin system, people are still able to build their own on top of it, right? So, this is just how it's supposed to work, right? So the fact that we see things like that kind of speaks volumes to, I think we're down the right track on where this stuff needs to be.
The real elephant in the room is state. Everyone that's been going out there and doing big Docker implementations have just been saying, okay, so we can horizontally scale this stateless web backend or whatever it is they're doing. For a lot of people, the answer is just use attached storage somehow. But for a lot of use cases, that doesn't work. Now, I guess at CoreOS, you're seeing a lot more use cases than for example, I am. What's your take on the state situation right now?
So nothing has changed, right? So when I think about containers, I think of a better package manager and more isolation for normal Unix processes. So if we were to step back maybe 4 years, This was equivalent to RPM install Apache. Maybe you chroot it and run it as non-root. And that was basic container, right? Definitely not the same thing we have today with containers. But you have the same problem. How are you managing state with your normal binaries on your system? Containers don't do anything to change that story, right? But it does make people start to think about that problem now that we feel that we've solved the package management and distribution problem of an application. So now we're starting to focus more on the puzzle that has always been missing for a lot of people. How do you have a highly available distributed file system, right? This is really tough to do in the cloud, right? If you're in the cloud, you have, most cases you have poor networking, you have poor disks, and then you have, maybe open source implementations of these file systems that aren't as robust that can handle high latency. Now, if you're in a real data center with real good networking links, low latency, some of these things like Ceph will run well there. It's going to take a little bit more work to make them run in, a $5 DigitalOcean instance, right? You're going to have to kind of beef that up to get the results you're looking for. So I think a lot of people, when they talk about this story, it's like they see the benefits of containers, they like running on the cloud platform, but they don't necessarily meet the requirements for a distributed file system, right? That's a new area for a lot of people. So yes, one of the easiest things to do, which is currently being addressed in Kubernetes, is give people a way to automate this idea of scheduling a pod to a machine and attaching storage at runtime, right? So this kind of gives you that late binding feel of moving the storage where the actual workload needs to be. And the second problem is a lot of the systems that we have available, like Postgres and MySQL, they are really attached to the node, right? Wherever you put that volume, wherever you land that database, you almost have to pin it, right? Because you can't just swing 4 terabytes of storage to a new machine and expect things to work. So this is I think these are we're conflating a couple of issues here, like having tools that know how to replicate their data. This is what etcd attempts to solve, but it's for a very small specific data use case. And then on the other side, for these non-apps, non-clusterware applications, just pinning data is a very, very hard problem. So we'll probably see more automation tools that just help you automate that part. But nothing changes with containers from my viewpoint.
One of the areas I hear about a lot at the moment is as people are starting to move towards these sort of very agile little bits of software flying all over the place. The end goal is resilience, right? I want to be able to lose US East Coast 1 and be okay. And one of the things that comes up a lot when I'm discussing with people in the storage area is they say, yeah, we can just use EBS, right? It'll work. But a lot of people don't realize that EBS only replicates at a zone level. And replicating between zones is left up to the end user. So I think as we start to move to these more sort of distributed models for software, we're going to see a lot of action in this area.
Yeah, I think everyone is learning about the hard problems of distributed computing, right? I think a lot of people got the notion or had the perception that they were actually doing real distributed computing because they had maybe 5 instances behind a load balancer. Really, they just had a bunch of machines, right? They didn't solve the hard problems of consistency, replication, and those bits. So now I think the reality started to set in that, wow, these are really, really hard problems, and this is why you almost need new solutions to solve them.
So this is one of the things we see now a lot with there's more and more posts coming out about like microservices in the real world. And one of the quotes I heard, and I cannot find it, I was trying to find it for someone the other day, was, now you just made all your errors runtime. And I think that's sort of perfect, right? Everything's just somewhere in a pipe these days.
Yeah, and I think that just speaks to people really understanding what they're building, right? I don't think everyone needs a monolithic or a microservice app. Some things probably make sense to be monolithic, right? You could break up Microsoft Word into a distributed microservices running on your laptop, but it probably makes no sense. So I think people are just really learning. So what's exciting is people are actually discovering this stuff in large scale. No longer is this confined to the Google, Twitters of the world. Now every startup, mom and pop shop wants to talk about microservices. So it's good. The conversation's happening.
So moving away from specific tech and looking more towards the future, first of all, apart from Docker Runstad meetup on April 16th in the Netherlands where you're going to be speaking, are there any other must-see events in 2015 that you're looking forward to?
So I've been speaking a lot in a lot of places lately, so it's probably too many to name them all. One that passed, which is late in the past, was Configuration Management Camp. I really enjoyed that one. GopherCon is a huge one to me. GopherCon is happening in Denver this year, and it's a great conference. A lot of people from the Go community get together, and they're solving a lot of these problems around distributed computing, microservices. As you can see, a lot of the tools solving these problems are also written in Go. So you kind of get a collection of those folks in one place for 3 days. It makes for an exciting time.
And so in your work, you're traveling all over the place and you're transmitting a certain message, but you must also be getting a lot of information back. So 2-part question. First, what are the big sort of stumbling blocks that you're hearing, or the big sort of question marks that you're hearing from the community now? And 2, based on that, what are the big exciting developments for you? I mean, if Docker was 2014, what's 2015 for Kelsey Hightower?
So I'll answer the 2015 one. So for 2015, Kubernetes looks like just, a big game-changing thing for everyone. I like to joke normally that instead of Google giving us another white paper, they gave us an open source project. And if you look at the people working on that project, these are the same people that have built internal systems at Google. So they're bringing in, a decade plus of how to do this, how to do it correctly, how to do it wrong, and how would they do it given another chance. So I think we're witnessing this live, commit by commit. So Kubernetes is very interesting to me because it solves a lot of the problems we've been trying to build for a very long time. So that one has my attention right now. I'm a core contributor there, and I really think it's an exciting project. Now, for the second question, when I'm on the road, it's funny. I think we're living in the GitHub era of software development and usage. The minute you check in a project, people want to run it in production, right? Forget the documentation, forget the learning, forget kicking the tires. People want to go from zero to production in like 5 minutes. So the benefits there, you get people adopting new technologies pretty quick. So there's a plus there. But the downside is people are adopting some of these technologies and not really knowing the trade-offs they're making. For instance, if you adopt a highly consistent key value store like etcd, then you need to understand the operational demands of a system like that. It's really easy to deploy, easy to get started, but it's really chatty on the wire. And some people aren't used to that level of clustering and HA. So, I think it would be really nice to see people not stumble over the fact that these are new things, and it may help to kind of read the docs a little more, ask questions, kick the tires before you rebase your entire infrastructure on something that you just found on GitHub or read in a newsletter.
Okay, so Kelsey Hightower's two top tips for 2015. One is Kubernetes, and two is be aware of the trade-offs.
Yes.
Kelsey, thank you very much.
Fantastic. Thank you.